Good morning, everyone, and welcome to this session organized by the project EUH4D. We are in the project in the context of the Data Week 2022. In the project, we are especially happy and proud to be organizing this workshop because today we will present outcomes and results and findings from one of the most relevant activities that we are running in the project, which are the experiments proposed by SMEs selected through different open calls that we are running through the project. So now we will count with the testimonies from some of the SMEs in this program, and also with the comments and vision from some of the partners involved on those activities in our project. My name is Daniel Alonso, and I am responsible of promotion and positioning in ITI, a research and technology center in the Valencia region in Spain. And I am also leading the AI Spaces group of BDBA from 2019, and I am also coordinating this project, EUH4D. Before moving ahead in the presentation in the workshop today, I would like to present to some of you not so much familiarized with EUH4D what we are doing or where we are achieving in the project EUH4D. So the main purpose of the project EUH4D is to establish an European Federation of data-driven innovation hubs. So here you can see the map as per the federation is today. So we already achieved to bring together 30 digital innovation hubs on big data coming from 30 different regions covering in total 20 countries. We have also established the ways of collaboration, and we are collaborating very actively also in the experience that you will see today, but also in many other activities that will also be presented by my colleagues in the project later on. Okay. The main outputs of this exercise, as you can imagine, we are developing several assets, but the main output from this exercise is what we call the European Federated Catalogue. On the one hand, all the initiatives, all the hubs are bringing together services, data sets, courses, and other assets to build this so-called pan-European Federated Catalogue that you can see here in the upper part of the slide. But also at the same time, each hub is personalizing this general offer based on its specific needs in the requirements from this ecosystem, and also the needs of the SMEs in their respective ecosystems. From that, we can address the needs again of the SMEs in our respective ecosystems to run experiments, also to test their products and services before going to the market, and at the end of the day to helping them in the journey towards data-driven innovation products. By doing that, we are again putting in contact the hubs and SMEs all around Europe, and based on this offer, we can again foster cross-border data-driven innovation and experimentation. And today we are going to focus in this last part of our project, which are SMEs and experiments. So as I mentioned before, for us, experiments is a key activity in our project, not only just because we are, again, running those experiments that some of the SMEs will present later on, but also because we are achieving with that many objectives in our activity and in setting up the model of the federation. On the one hand, of course, we are attracting end user to use the assets of the federation. We are supporting SMEs and startups in the creation of innovative data-driven solutions and services. We are, through the experiments, collaboration between the hubs of the federation is encouraged and fostered. So the experiments show a very practical example how hubs are collaborating in a cross-border basis to solve real challenges proposed by SMEs external to the consortium. We are also checking the level of satisfaction of the SMEs and the users, also improve the service delivery, the joint between all the hubs. And we are also trying to keep the demand side coming to federation, just to build ecosystem and to involve also the view of the users in the general strategy of the federation. At the end of the day, what we are trying to do is to contribute to the creation of European common data spaces by mobilizing data, by putting in contact different stakeholders, by generating new data sets, and also, again, contributing to these challenges of the European common data spaces. For that, in the project, again, experiments is one of the core activities, but around the experiments, there are also many activities that we are running. On the one hand, of course, we are testing our technical developments also using the experiments. We are also not only applying an ethics framework to the experiment, but also learning on the fly. And later on, we will show you our main findings in ethics. Impact, the experiments also are supposed to contribute to the impact that we in the project are creating with the different activities and results, exploitation, because it's not only about developing new services, but also to define a way how the SMEs can get out the best out of those experiments and results. And finally, and of course, this workshop is part of it, to contribute to get visibility and promotion to the project, to the federation, and to our activities. So as you can see here, for us, experiments are key, and also this is why we are devoting this session to explain you a little more about what we are doing, and of course to learn to hear from directly for the SMEs the results and the activities. Okay, I wanted also to highlight that the way through we are selecting the experiments is through 3 open calls that we are running through all around the project. 2 open calls already happened, so we are already close, and we are working with the SMEs. The first round already finished, and some of them are here. The second round just started, but now the third round of the last open call will be launched in September this year. So I encourage those of you that could be interested in stay tuned, because we are providing what I include here in the slide: access to advanced assets on big data, to the whole catalog, technical and business support from the hubs in the consortium, digital and business skill, also financial support up to 60 euros to fund your experiment, visibility and promotion, and to the support on the elaboration of an exploitation plan. So yes, my last slide is to present you the agenda of the session, and I am really proud to see this set of relevant speakers that I will present later on. And I want also to thank all the speakers for you to be here. Okay, so the core part of the presentation will be around the SMEs and the experiments. And again, I personally thank to James from BitBrain, Inigo from Forest, Marcelo for Geomatics, Bertrand from KenTU, Caetano from Latitude 4.0, Kirill from Tunnel, and Andre for Binac to be here today. They already finished their experiments quite successfully, and you will hear from them again results and outcomes from the experiments. But before that, Ana Garcia, Secretary General of BDBA, will provide some context. We'll talk about the federation that we are creating. She's the one leading this activity in the project, and she will again provide more aspect about the federation. After the experiments, my colleague Till from Karlsruhe Technical Institute, he's our, let's say, ethics manager in the project, will talk about what the main learns and findings from the experiments regarding ethics. After Till, Adriana from CARSA will talk about the exploitation and how we are trying to support the SMEs and the experiments in the exploitation part. Then Nuria de Lama from IDC will talk about the impact and how we are using those experiments also to contribute to the impact of the project. And finally, Justina from Digital SME Alliance will provide the view from the SMEs from a European perspective. Okay, so I hope you will enjoy the session. Again, a very full-packed session, and I think it will be interesting. So with no more preamble, Anna, I will give the floor to you. And again, thanks all for being here, and that's all from my side.
Thank you very much, Daniel. I also feel very honored to be invited to this session with this group of innovators today. So it's really great to be part of it and to have the possibility to share this session with them. So my presentation is mainly to position the federation in a larger landscape, and somehow it's given to the audience, to our audience today, but it's something I wish I could have a dialogue also with all the innovators that we have in the call, as you know, it's important for us that this federation stays as a long-lasting instrument to support innovators like you. But let me go through the slides. And well, Daniel already introduced me, so I don't need to do it. Ana Garcia, Secretary General of the Big Data Value Association. So I start from what Daniel ended, or part of his presentation. So the federation is a combination of these hubs, the federated catalog, and the experiments. That is the part that actually we'll see today with more details. But the important part, and that we will have also presentations later on, is we want to generate impact. And we want to generate impact in the long term, okay? And this is the very important message. And for that, it's important to understand that this federation is not a one try, that some partners, they came together and decided to build a federation for 3 years and bye-bye. So the federation has been a result of many years of work, of many companies in Europe, together with many competence centers that are mainly the organizations behind the hubs, and the European Commission, the institutions, and also with some national and regional policy makers as well. This is the part that you can see, from 2014, and we don't have time to go into details, but the important part is there is a very strong foundation, and it's not only the foundation of those ones behind the hubs, but many large companies, other small companies, many research institutions. And as I said, of course, this federation was written in the policies of the European Commission that this needed to happen. Okay, so here we see the federation, let's say, was born as a project. Of course, we are very happy that we have this project to build capacity. But the important part, as part of the trajectory, the federation engages with new partnerships, and I will give you some more details with other activities that are happening, because the landscape is evolving dramatically in Europe. So the important part is there is an evolution where the project exists, and we are really working very much to position it for the post-project part of the federation. Here I talk, you see in the center, I put together VDBA, so the Big Data Value Association, and EUH4D, because this is a joint community. The iSpaces, the Big Data Innovation Hubs were born as part of the Big Data Value Association community. And together we do this link in between the local and regional ecosystems and the European ecosystem. And I explain here how we make this entry point for SMEs in Europe to go to this complex and probably very abstract ecosystem in Europe. But at the end of the day, I think the message, and then we will go more to landing into reality, but by entering as an SME, as a startup in the federation through the hubs, I enter in a very rich landscape of initiatives, partners, and also connection with policies and with the standardization discussions, etc., etc. Important, here we mix a very large network of large companies, research institutions, and I said in Europe, together with 30 hubs today and growing. And this, you will see later on that this continues growing. And you see on the top that we are very tightly linked with the European policies. And this includes a data strategy, includes AI strategy, and also everything that has to be with the digital transformation. So with the adoption of all these technologies and the value creation. And also we are connected, you can see it here, with everything that has to be with the regulations as well, because the regulations will have an impact in the market, and they are very complex, and they will affect a lot the work that in particular the smaller ones will have to do in the next few years. So it's very important to establish a very, very tight dialogue with the policymakers and then the standardization bodies that will define the standards to comply and conform with the regulations. That's for data, and that's also for AI. But we see in the bottom, and this is just part of it, because the network of collaborations that is built through BDBA and EUH4D is huge. But we wanted to also show that this federation was one of the major results of the big data value partnership that we had for years with the Commission. There are other results, but this is one of the major ones. And we see now we are a part also of this AI data and robotics partnership. And this federation will be a major contributor to this new partnership. We are also through BDBA partners in EuroHPC. Here we are talking about computing capabilities, so important for big data experiments and for and also for AI. And here we are having so many discussions also with the competence centers on HPC. So we can really join forces there. We are also part of this Data Spaces Business Alliance, so with GaiaX, that is so popular these days, so I don't need to explain. Also with International Data Spaces Association, part of the federation as per today, and helping us really to federate data and services, and FIWARE. So really we can make these connections, and you will see later on that we make connections between this federation and other hubs to complement each other, and again, to open doors for impact to those ones defining the experiments. And of course, we link to other instruments that are funded by the European Commission. In particular, Daniel mentioned the data spaces. This federation is becoming and will become a very important instrument to support the development of data spaces. And I'm sure it will collaborate very tightly with the Data Spaces Support Center that will be launched after summer. Very connected, EUH4D fits perfectly and takes a very important role in this European data landscape, collaborating with all these initiatives and actually as competence centers, as hubs, as federation, looking from the infrastructure to the services and giving the overall stack of services for the experimenters so available. So this is very, very important. And then I pass also to an ambition of growing, and it's only a few more slides from my side. This one is an ambition to grow. So this federation needs to grow not only in size, maybe here I'm talking too much about the size, but it's also in capabilities, in possibilities, in services, okay? We continue growing through the different open call for AI spaces. We are about to launch the call for this year that will close to our event in November. Then we are already defining how to collaborate with the European Digital Innovation Hubs, and more very soon will be said about it, as already some of the members of the Federation are building corridors to really use the Federation very smartly for these corridors. As I mentioned before, we are part of this Data Spaces Business Alliance. You can see here like a larger map of hubs from all these organizations that are now starting to have discussions how we can leverage on each other and how can really coordinate our activities. And of course, there are a lot of potential to integrate new hubs in Europe. And this is for me, in particular, for those of you that will be speaking after me. This is very texty, sorry, so we focus on this. We have like a dream, so to speak. It's good to have dreams of what we want to offer, in particular to innovators, to SMEs, to startups. So we start talking about, okay, we offer experimentations. That's what we will see today. But we also want to help scaling. Of course, the go-to-market, scaling, you know, is how we grow this, how we internationalize our services, how we find partners, to how we open new markets. So that's something that we can really offer through this federation. And for those that will speak after me, it will be very good because, of course, we have key questions for you. I know there won't be a dialogue in this session, but I leave this open for a future session that we have key questions to answer. And this what journey will give to the experiments that will be presented today for the future, how we can support them to really navigate new sources of funding, new projects, new activities, new markets. And this is important, what trajectory, journey we can give them. Another thing beyond the people that are here today is, you know, now this is a project, we have European funding, we can fund open calls, but we really want this not to continue without funding, but, you know, that is sustainable, and we make sure that is really the value proposition works, even if we don't have these open calls all the time. And also we want to make sure, I explained that before, this is my last point, but it's also a question mark. We want to make this federation a very important entry point for these SMEs, innovators, startups, that many times they work more locally or regionally. They don't have the possibility to be in this complexity of the European landscape. But through the federation, they can enter this landscape. But now is how we really create impact by building good collaborations for them, opening these new markets, being really a source of new knowledge for them. And how we make this federation a key instrument for the data economy and also for AI adoption. And that's all from my side, Daniel. Thanks again. I'm really looking forward to the presentations that are coming after me.
Thanks a lot, Anna. Very inspiring as always, and also very challenging, your question also for the SMEs. So now, after this context, very nice explained by Anna, we will move to again to the SMEs and the experiments. And the first to present will be Jens from BitBrain. So Jens, if you are ready, the floor is yours.
All right.
Perfect.
Can you see that? Great. Okay, yeah, so thank you very much. My talk is going to be about assess sleep quality assessment by a data-driven approach based on a wearable neurotechnology. I'm Jens Klinzing. I'm R&D neuroscientist specialized on sleep and cognition, and I'm the lead of the sleep innovation program at BitBrain. So BitBrain is a neurotech company based in Spain. We are specialized on high-tech physiological monitoring with a strong focus on neuroscience. We offer integrated hard and software solutions. That means we provide the devices, but also the data analysis, the decoding of brain states, and so on. And the applications of our products span human behavioral research, both in the private and the public sector, but also marketing and the health sector. Yeah, and the health sector is what this project is about, in which we aim to improve the standard of monitoring and assessment of sleep. So the problem is the following: sleep is essential for health and well-being. However, sleep problems and sleep disorders are highly prevalent in our society. And this results in a lot of downstream effects, a lot of health problems in the population, human suffering, and huge economic costs as well. And this is especially the case because sleep disorders nowadays are often not diagnosed and therefore not treated. And tackling this problem would require accurate sleep diagnostics that are actually available to people. Yeah, and as a result, because that is not the case right now, patients are just not getting the treatment that they require. But what makes nowadays sleep diagnostics so complicated and so expensive? So down here, down in the bottom left corner, we see a current device that is generally used, the so-called polysomnographic device. And as you can see, it's a quite complex apparatus. And the advantages of medical equipments like this are clear. They have a multitude of sensors, they have high accuracy, but because these systems are so complex, they also have a lot of disadvantages. As you can imagine, this is something that you don't set up yourself. This is being done by a trained person in a laboratory, and therefore it is not a very natural environment. It's not very comfortable. You're just not going to record the sleep that the way you would when you sleep at home. Also, the signal analysis is being done manually. So what kind of analysis am I talking about? You see in the second picture on the bottom, you see a polysomnogram. This shows you the evolution of sleep stages over time of the patient. And this is something that is currently being done manually. So a person is literally sitting down for 8 hours, like going through the 8 hours of recording, going through every 30-second page of the data and notes down the sleep stage, the arousals, any breathing related events. And as you can imagine, all of this together results in high costs, either for the individual or for the healthcare system, and also long waiting times. On the other side, we have so-called activity trackers. And you can see pictures on the bottom. Those activity trackers can be worn on the wrist or even on the finger. And they're super easy to use. They can be integrated into your daily life. And they often come with a rudimentary data analysis as well. But the disadvantages of these technologies is that they have very low accuracy. They're just not good enough for diagnostics. The analysis is rather coarse, so telling you good, bad, or mediocre sleep is just not enough for medical applications. And one of the reasons for that is that they don't record brain activity in most cases. So BitBrain's solution brings together the best of these both worlds. What we are developing with the help of EUH4D is an easy-to-use sleep monitoring headband. This headband is super comfortable. It's no comparison with the medical system that you've seen before. It's based on ergonomic, smart textile technology, and it can be used independently at home. So you take this home, you record your own sleep. what do I mean when I say it records sleep? It actually records brain activity as well as oxygen saturation in your blood. And then it uses artificial intelligence to analyze these data. So there's no manual scoring necessary. And then it provides a well-structured feedback both to the user and their physician with medical grade accuracy. So when you develop a product that depends heavily on AI like this product, it is an important building block to acquire a lot of annotated high quality data. And this is exactly where EUH4D gave us a giant support over the last year. So as part of the EUH4D experiment, we created a large multimodal sleep data set that consisted of data from our headband, so brain activity and oxygen saturation, but also environmental sensors to get a better feel of how the laboratory looked like, and the medical comparison device. This is on the picture on the top left. This is where all these cables come from. They all come from the standard medical grade device that we used for comparison. And to do those experiments, I cannot even stretch enough how much effort this was. Sleep studies are generally a large effort, but this one in particular. So we started with our company, we started from scratch. We built sleep labs with 2 beds and all the technical infrastructure. We had several regulatory hurdles to overcome. There was the ethics approval, of course, to do all these experiments with human subjects, but especially what was especially high effort was to get the approval for testing new medical devices from the local notified body. And I gotta say, I have conducted hundreds of experimental nights in my life at over 8 years at the university, but this experiment was particularly difficult and complex because we were working with completely new technology with our textile sensors. What we did was we acquired 30 full nights of recordings, and then we had all of these recordings being scored, so annotated by 4 professional sleep scorers who assigned sleep stages to each part of the data. And then we trained our AI algorithms to do this job automatically. And in addition to that, we developed a collection of additional algorithms to create even more detailed analyses. And together, this was a substantial effort for us, for the company, but eventually also a very important success for us because we now can rely on this well-annotated, high-quality data set. So based on the data collected, what we could do was we could test our sensor technology in a realistic setting. We could use the data to train our artificial intelligence algorithms to analyze the structure of sleep, these sleep stages, sleep events, and also quality, and do that robustly in real time. We could use the results of the analyses to better understand how the environment influences our sleep. And this is a task where we profited a lot from our partner, Aragon DAH in Zaragoza in Spain. We were able to develop ideas for the technical infrastructure that is going to be necessary to turn our developments into a product. And here we work with our EUH4D partner, Cedar in Dublin. We learned to create the maximum value from our data and our algorithms with No Center in Graz. And we think we produced value not only for us, but by publishing the data at the end of the project, also for other companies in the sleep health sector. So to summarize our success in a few numbers, so with our newly developed textile sensor headband, plus our AI technology and the data set that we acquired with the help of EUH4D, we have now arrived at an accuracy level of our algorithms at 70 ±5%, which makes these algorithms already ready for consumer applications. And this is in a realistic scenario. This is not some best case estimate that you hear sometimes. This is realistic scenario. And we already set out to go further from here. Our next goal is to improve the performance of our algorithms to 80%, over 80%, which will open the way for medical grade sleep monitoring, to get it certified for medical grade sleep monitoring analysis and diagnostics. And once we're at this level of accuracy, we can also move from just monitoring to interventions. We can use our technology to realize personalized therapies for sleep-associated disorders, and this will include non-invasive brain stimulation. All right, so with this, I would like to thank the organizers of the Data Week for this great event, everyone at EU Hubs for Data for their support over the last year, our DIHs, Aragon DIH, CEDAR and No Center for their support in the experiment, and everyone in attendance for their attention. Thanks.
Thanks a lot, Jens, for your presentation. And also thanks for having worked with us. Yes, a very challenging experiment. We never thought that we would have this kind of sensitive, also challenging experiment part of our program. So thanks a lot for your effort and your presentation. The next one in the list is Fora Forest, led by Íñigo, that will talk now about their experiment. So Íñigo, we can.
Okay, so good morning. Okay. Thank you very much. Thanks for having us today. I'll be presenting this second success story. It's called Forecast 2.0, Escalating Forest Intelligence, a big data-driven step forward. My name is Íñigo Lizarralde. I'm the CEO of Fora Forest Technologies. Fora is a forest technology and innovation company. We are focused on the assessment of forest resources using remote sensing, especially LiDAR technology and satellite, and artificial intelligence. We have an expertise of more than 30 million hectares processed with LiDAR, over 60,000 satellite images processed also in 7 countries. Our team has been involved in more than 60 or published more than 60 scientific papers and involved in more than 40 funded projects and 18 intellectual property registries. In our team, there's more than 30% of PhDs, more than 40% of women, and that's something different for a forest company. Even if we're in forest, almost 40% of the people of our staff is somehow involved in software development. That's not very common for a forest company. So here you can see the evolution of Fora since we founded it in 2013. So we've been adding different technologies, different tools, more people, different projects, and so on. And starting in 2018, we started with our software development department. We started to create our own software. And in 2019, 2020, we created Forecast. Forecast, it's our platform for data, LiDAR, and satellite automatization. And that's where we had, or when we had the opportunity to have this EUH4D data open call. So through that project, we've been able to develop Forecast 2.0. So Forecast, it's basically a forest intelligence tool. It's a web application where anyone in the world can get their forest and know about the stock of the forest in means of wood, biomass, carbon, or whatever. But not only the stock, but through satellite, we can monitor those forests. So we can detect changes every 5-7 days, depending on satellite. So we can detect changes that they're due to clear cuts or forest fires or pests and so on. So we had, as I said, we had Forecast. We had this first version of Forecast. And when we had the opportunity to start working in EUH4D data, we have a clear challenge that it was the scalability. We wanted to do scalability in three parts. First of all, a computational scalability through the architecture and parallel computing. Also, the geospatial scalability, so creating algorithms into geospatial for geospatial processing scenarios. But we also wanted this business scalability, especially focused on internationalization, not only from the technological point of view, but also focus more on market. So the results we obtained, first of all, we designed a new architecture. So we came from just one instance at a time to having parallel instances to we now can solve different forest inventories. So we avoid Kpis and that makes this parallel computing able through OpenStack. Here you can see some of the examples. We did some proof of concept with different scenarios, different instances, different inventories. Here you can see some examples on how it looks. A forest inventory where each pixel gives you information on wood heights, diameters of trees, and so on, whatever you need. Of course, we used new methodologies for algorithm development. So we needed to cope field data, especially for Spanish National Forest Inventory, but also other forest data sources. And we needed to cope that with spectral satellite information from Copernicus. So we needed to do it without clouds. So that's why we created these algorithms in order to do this through this geospatial toolkit to create this seasonal forest data. So what we created is using random forest, we developed seasonal maps with the most representative values of each spectral band of the satellite being spatially distributed. So what we have here, it's like an image of a whole season, avoiding the usual problems of satellite information, that's climatological factors such as cloud. So we obtain cloud-free information for each season. It can be done for each month. So, but this is one of the things of the project that help us quite a lot in our developments. But also we have these results in terms of the big idea report, the report on business. So this is a two-way driven approach. The first one is business. We had a lot of meetings on and a lot of advice on internationalization, and we have like two very focused target countries analyzed and with our report, so that will help us quite a lot. But also from the tech-driven approach of this report, we have a technology plan roadmap that help us from the technological point of view, help us target the market more easily. So we think that was a very important thing, not only from the data, from the technology part, but I think we need to reach better market. And that was, I think it was a great idea to be involved in this part also. So the services and the support we had from EUH4D data. Okay, so we used the geospatial toolkit from HPC4 Poland and PSNC. And we had this big idea consultancy from the EUH Aragon. I'm talking about the datasets. We especially used data from Copernicus, satellites Sentinel-1 and Sentinel-2. So lessons learned. Well, first of all, it's clear you need advice to go further. I mean, with help of others, sometimes you just have others have other points of view, other expertise, of course, other data, other technologies that will help us go further. And the other thing, and that goes quite a lot in the line of what Anna was saying before, I mean, networking never hurts. And this kind of project, it's really a good example of that. And we've been seeing how DIHs or BDVA or the SMEs inside or outside the DIHs, but collaborating, this environment is the way to go to develop more technological products, more data-driven products, but also more focused on reaching the market. So I think that's the best lesson learned on that. So finally, with all of that, we were able to finally have our new version of Forecast. So with Forecast 2.0, now, when you have your forest, you can use our Forecast so you can decide on your forest. So that's Forecast. Easy, fast, and updated. So thank you very much. Here you have the website of Forecast if you want to take a look, and also if you want to drop us a line at info@fora.es, just do it, and we'll be in touch. So thank you very much.
Thank you, Inigo. Thanks a lot for your presentation. Also, the last summary, the lesson learned, quite useful. I think your experiment is a quite very good example how EUH4D has been used to scale, to bring closer to the market your product. And we are really happy that also it was useful for you. So thanks a lot. Okay, so now our next presenter is Marcelo from Geomatics, and he will talk about the Damas Experiment, right, Marcelo? So we can see you well, and now the floor is yours.
Can you hear me?
Yep, perfectly.
Okay, I will try to share my screen. Do you see my screen?
Yep. So yeah, you have to switch to presenter mode and.
Yeah. I'm switching.
Okay, there you are. Thanks a lot.
Okay, so I'm going to talk to you about the Damas Experiment, which means bringing together ocean, supercomputers, and AI in actions, artificial intelligence. We worked on this project with a couple of experienced people, myself more on the business side and Matteo on the technical side. But we also had 3 young guys, Federico Croce, Jacopo Modica, and Raffaele Scarano, which are young graduates working in software engineering and artificial intelligence. That was a very good step for us. Let's go to the Damas objectives. So to work under EUH4D and to develop an AI-based model for sea state analysis and forecast. How are we set our objectives? Basically, we started from the INEA model that is already delivering on a daily basis the analysis and the forecast for the next 24 hours of the status of the Mediterranean Sea. So this was the first objective. Let's try to match what they are doing with the physical model. The second step was improved geospatial resolution to 1 by 1 kilometer. Currently, they are working on a 3 by 3 or 10 by 10 kilometer. Copernicus is in the same range. Then the other key point was to improve the temporal resolution, not going 1 hour by 1 hour, but to downgrade that to 30 minutes. And the most important was to have a refresh every 30 minutes, because normally these forecasts from INEA and from Copernicus core service are provided once a day for the next 24 hours. So when you are in the middle of the day, you are still looking at something that has been forecasted 12 hours before. Whilst here, we wanted to have refresh of the information every 30 minutes. And then we wanted to interact with the marine experts. So we worked as a partner within the project with the Cineca, who made us available their HPC infrastructure. And we heavily used that for training of the AI model. And then we were also supported by an external advisory board composed of people experts in the technology, in the ocean environment, and also in the business environment related to that. we considered the number of sea-state forecasts on a two-dimensional basis. There could be in the future the possibility to go also a little bit inside the sea, and so to know more about the structure of the waves of these parameters that changes from the surface to the next 5 meters below the surface. So waves in various ways, the peak, the period, the direction, and then the salinity, the temperature, and the wind components. So initially, we had to develop an accurate georeferencing of all the different data. We had the data from the meteorological channel, we had the INEA data, we had satellite data, and atmospheric variables. So everything needed to be very accurately georeferenced. Actually, we did it in 2 steps, the initial step, and then after the results of the midterm review, we had to go back and improve the georeferencing of the data. And actually, this brought quite a significant improvement. Second step was to identify which architecture of artificial intelligence to use. And we tested a number of them, and we selected what seemed to be a promising one. Then we did the trials, we did the training, and this brought us to a lot of optimization work to improve the accuracy of the results, and in a second phase, to reduce the time needed to make this processing. And in this activity, we have adopted more than 200 changes, 200 variations to tune the selected AI model to produce the best results. Then, because of the, as we have achieved a very short time period for the production of the forecast, we also experienced the ensembling of different models and of different initial variables conditions. Ultimately, we had to present these results. So we have produced the table showing the KPI for, let's say, formal motivations, but we have developed also a visualization platform that can show very clearly the evolution of each parameter over the time frame of 1 day or even more, and changing the various parameters under analysis. So here are the results that we have achieved. So we had for the runtime 30 minutes as a target, and we achieved 15 minutes on our server, not on the HPC. So in HPC would probably run in terms of seconds. Geospatial resolution has been fully achieved, and about the wave, we had the point accuracy and the aerial accuracy. And you see on the right column that we have achieved a very good performance. Just a couple of them on the aerial accuracy have been just reached. Then regarding the salinity, temperature, the sea height and wind components, you see that we have fully achieved our targets. Let's see the interface. So we have created, also for comparison reason, a platform that can show over the 24 hours the evolution of all over the Mediterranean Sea. And you can just move the cursor back and forth and you see that. And here you see the comparison from the INEA model that we wanted to approach and the Damas sea surface height that we have produced. And you see that they are pretty much in line. Then we wanted to go a little bit more deeper into the analysis. And so we looked at the various parameters. Here we have a total mean value direction and the sea surface wave significant height. And you see how well we have approached our model, the INEA model. And you see how on the left side, the visualization effectiveness of the tool, and we can move the point of analysis everywhere in the area. So we have on the left side the synoptic view evolving over time, and on the right side we have the capability to make point analysis. This is another parameter, the total mean period and the total peak period. And also in a very dynamic situation, we were able to approach very well the INEA and the INEA model. And actually from their feedback, they were very pleased about this, because when you operate a physical model, normally you have a high level of complexity of interconnected variables and equations. So for making evolution of these models, you need a lot of time. You need to bring back the team that has performed the basic model. And so this is a little bit cumbersome and somehow risky. So it is not done very frequently. Whilst with our model, you can do tuning, you can add another layer of information. You could add the Aeolus wind information produced by Aeolus ESA, a European Space Agency satellite. Let's see what we are planning for the future. A second step that we would like to implement is to further tune the AI model in some specific areas that need more, let's say, focused attention. For example, the Gibraltar Strait. We want to use more satellite data, not only the radar data from Sentinel-1, but we would like to use also other data, as I mentioned, the Aeolus data from ESA satellite. Further explore the capabilities of ensembling various models and different initial conditions in order to have a better of the expected evolution, introducing 3D components, as I mentioned at the beginning. And then once we have a very good model over the Mediterranean Sea, try to go outside, maybe starting from the North Sea, but also going a little bit more into open waters. And here we are planning to use transfer learning techniques. And for the time being, we are comparing with the Copernicus CMEMS service and INEA service. But of course, having more information from satellite, it would be very useful to have direct comparison with real observation, not comparing our results with the models. And finally, a third step, which we are in the process of activating, is to start contacts with the potential customers. Industry on the ocean energy side, the shipping, and also platform operators. We had a couple of contacts already, and presenting to one customer, we got a very good input about which parameters we need to improve, because it's not maybe so important to be precise on the height of the waves. What they asked us, for example, is when the waves are going to be above 2 meters and for how long they will stay above 2 meters. Because this means is a period of time that they cannot operate their logistic or operational activities at sea. So that was very illuminating to us. And also we would be more than willing to develop partnership with other players, because we understand that our knowledge of the ocean environment and the knowledge of the business linked to the ocean needs to be complemented by some partners. Thank you for your attention.
Thanks a lot, Marcelo. Really amazing what you have achieved in a so complex system as the sea, as you mentioned before. And also nice that you also have in place the next steps, so we can talk if we can be of any help in your next steps of your Damas product and experiment. Thanks a lot, Marcelo. So now the next company, the next innovator will be Kpis. And sorry, before I mention Bertrand, but it will be Sofia doing the presentation. So now, Sofia, if you are ready, the floor is yours.
So I hope that you can see my screen.
Yes, perfect.
And here we are. So thank you, Daniel. Thank you very much for inviting us in this very nice event. We are glad to present here. So my name is Sofia Sarchie, and I'm the data scientist of Kpis. Kpis actually is a newly formed startup company. It's around 2 years old, and it was created after 7 years of research and development activities in CEA, which is a world-leading institution in France. So Kpis realized that although cities are quite rich in data, they need some help in order to unify this data that are coming from different sectors in the city, analyze those data in order to get some insights, and then build some smart applications on the top of this data. So for this reason, Kpis is able to provide a unified access to data through an IoT platform, which is called SenseNact. On the top of SenseNact, Kpis is able to provide some AI algorithms, data analytics, and forecasting mechanisms in order to analyze and get insights from the data. Given this access layer and also the algorithms that we provide, we are able to assist the marketplace where other innovators and SMEs can build their smart applications for smart cities. Also, Kpis is able to provide its own dashboard, which gives a holistic view over the data of the city and also allows the city to define their objectives and tasks and also define their own KPIs and monitor those KPIs over time. So we could say that we are different because we are able to provide AI-based solutions using multiple parameters. Then we have a plug and play mechanism in order to monitor an environment in few seconds. We are able to develop connectors in just a few hours. And also we are working on an open ecosystem within a very large community of Kpis. Also, our experience of research and development gave us the opportunity to deploy in several different cities. So why EUH4D for data? EUH4D for data gave us the opportunity to work in a very interesting problem of encouraging the soft mobility and reducing the CO2 emissions within the city. In particular, we worked on optimizing the locations of soft mobility stations by considering social, economic, and environmental criteria. Also, EUH4D data gave us the opportunity to explore several data that are coming from the city of Barcelona and validate our solution in this city. Moreover, we had the opportunity to bring new data in the environment, in the ecosystem of EUH4D data, and also test and scale our solution in this dataset that corresponds to Paris-Saclay area. Also, in the context of EUH4D data, we had the ability to exploit several services that scaled our solution by accessing big data infrastructures and also improving some parts of our solution by utilizing some relevant analytical toolkits. Also, we received some very valuable business consultancy service that I will talk to you about this later. Let me now explain you a little bit more about the challenges of optimizing the locations of soft mobility stations. This problem is quite challenging since it needs to consider multiple parameters in the decision making. First of all, the first parameter is environmental. Within the city, there are different areas like rural, urban, or industrial that have a different CO2 footprint, and they should be treated differently from the city when deciding to deploy new stations. Then there is the social parameter. Our solution wants to ensure that there is social equity and inclusion of every different population group. And of course, the economic parameter, we are always interested in respecting the city's budget and deploying only the most necessary stations within the city. So in a nutshell, I could say that our solution was able to integrate a very large number of datasets. We integrate more than 260 datasets. We analyzed those datasets, and this analysis gave us the opportunity to detect the different areas within the city and address the environmental criterion. Also, we had the opportunity to get some insights, to provide some insights of those data, which helped us a lot to address which exactly social groups and populations needs to be encouraged for soft mobility. And given all these insights, we were able to provide 2 different heuristics in order to have some recommendations for the optimal locations of the stations. This work was published in an international conference, and also CanTU, within the context of EUH4D, had the opportunity to build the first prototype and first exploitable result, which is a dashboard on which we can plot the recommendations of optimal locations, and each such recommendation is also accompanied with a small explanation of why this location is considered as optimal within the city. Also, as I have mentioned before, we had the opportunity to receive a great consultancy service on the business domain. So we had the opportunity to define and explore our strengths and weaknesses, and build a model, a business model, which will allow us to exploit and also to promote our solution in the next coming months. Also, to sum up, I would like to talk a little bit about the lessons that we have learned during these months working with EUH4D. First of all, it was very interesting because we realized that cities do not always have the same datasets available. So each city has its own dataset, and sometimes those datasets differ over the different cities. And moreover, the cities do not always have the same priorities on soft mobility or even on the general mobility sector. So it is very important for our solution to understand, first of all, the needs of the cities, which was the case for EUH4D by talking to Barcelona, to the city of Barcelona. Also, we had our solution is very important to allow the cities to define their own priorities and KPIs, which we did through our prototype. It is considered very important to exploit the dataset that they exist within the city and the service, that they are already there, and utilize them. And also we are very interested into building solutions that can generalize and scale. And that was the case when we tested our solution in 2 different cities. So thank you very much for your attention. Feel free to visit our website and give any feedback or if you have any questions through my email. Thank you.
Thanks a lot, Sofia. Thanks for the presentation. I think your experiment is a very good example of how the hubs, beyond providing infrastructure, services, and so on, could be a contact point to the public authorities, also to the, to the ecosystem where we are based. So it's nice that this is done by EURECAT, and well, I think again a good example of this type of collaboration. So thanks a lot.
Indeed, thank you.
So now we'll move to the next innovator SME, which is Latitude 4.0. And Gaetano, the CEO, founder of this company. So the floor is yours, Gaetano.
Can you see my screen?
Yes, but not the presentation. We can see some kind of login. Okay, now perfect. Now,
okay,
now you are done.
Thank you, everybody. Thank you, for the invitation to be here to present our solution. Thank you also for Eureka for the support that we received during the experiment. Latitudo is a company that applies artificial intelligence to satellite imagery to offer to the cities data-driven governance. So the idea of our solution is to provide a series of actionable insights to identify problem and find the right solution to adapt to climate change and to be more resilient and plan the future. So in particular, in the case of Barcelona, we used our dataset together with the dataset of the city to create a new solution. So the capability to analyze using optical images the urban heat islands problem in the city. This is based on our proprietary algorithm that is trained on thermal images that have a lower resolution with respect to Sentinel-2. And so with this analysis, we identify where there is a problem of extreme heat or of heat in the city. And from this, using another algorithm that we have developed, we identify what is called environmental quality of life. This is to verify where are the problem of the city and where to operate to solve this problem and to increase the quality of life of the citizen. This is the model that we created. So is the end of our experiment is not only the data collection where we combined the data collection of from satellite also with open data of the city. So we used the open data of the city of Barcelona, our AI algorithm, and then the results on two types of sets. One is dashboard, and the other one is API. This is the analysis that we made. So we analyzed the effect of renovation activity and the carbon sequestration capacity in a couple of areas of the city. And see this, that's the urban cooling index after the effect increased. And so this is a positive effect. So the adoption of urban nature-based solution created an effect not only for the area where the new green space is created, but also for the surrounding, because there is an effect of mitigation. On the other side, also the carbon storage sequestration that is important for the effect on the environment is positive. And we see that is an area in this image on the left part where the carbon sequestration is very, very high. And we estimated the total capacity of the city to store CO2 carbon in the green infrastructure. And so this is a new algorithm that we are working on. So what are the data that we used from the city to integrate with our data from Sentinel? So it's the trees in parks of city in Barcelona, the street trees, the zone trees, and the park. With this data, we optimized and improved our land use, land cover data. And this land use, land cover is the input for our model of urban cooling index, carbon sequestration, and habitat quality estimation. So the first effect of this experiment is the capability that we can improve the land use, land cover. We tried to use the open coring cover, but the coring cover is not useful in a small environment like a city. So we are working now on this improvement or super land use land cover. It's positive that after the experiment where we reached all the KPI also in terms of the elaboration, we are applying this model also in other cities, in particular in Milan, in Turin. Yesterday we had a meeting with the presentation also with the city of Turin on the effect of the city of Turin. In China, we had the opportunity with the effect of this exploitation to enter in a consortium to monitor around 240,000 square kilometers of cities in China. And we are opening also other cities in the Northern Europe, small cities in Italy, but also different cities in the Northern Europe, like Tallinn and Vilnius. We have a discussion with them. So the effect is extremely positive, gave us a lot of opportunity. And thank you this program and for the capability to scale our company.
Thanks a lot, Gaetano. Well, just a very good, another example of collaboration with the city of Barcelona through EUH4D. So just to reinforce my previous message, here the collaboration with the hubs goes beyond the providing of infrastructure and services, but also to be in contact with the local ecosystems. Thanks a lot, Gaetano from Latitudo. And then we will go to Sweden. We have Kirill from Tunnel presenting the experiment. So we can see you well, Kirill, welcome.
Thank you. Good morning. Good morning, everyone. Hi, Daniel. Yes, sharing my screen. May I ask if it works for you? Is it visible?
Yep, perfect.
Good. Good.
So we have some black squares here and there, but I think it's Zoom feature, but go ahead. Let's see if we can manage. I don't think it's your fault, but
I'll try to hide Zoom. Okay. Yeah, so my presentation will be about Tunnel, which I'm the CEO of. It's about public transportation and data. And the experiment, which we worked with, both with EUH4D and the digital hubs. But I'll first start with the problem to give some context. So yes, it's all about cool solutions and technology and data processing and AI. But let's get back a little bit to the ground. I'm speaking about very small towns, which there are many around Europe, which do not have funds to subsidize public transportation. And in many of them, the waiting times for the bus could be as long as 30 minutes, 60 minutes, if there is any public transportation at all. And this is the result of the fact that unlike big cities, the small towns do not get enough funding from the state, and they cannot afford to keep many buses on the streets at the same time. Basically, that's the money problem. And it could be called a money and transport optimization problem, but actually it also has a very important social direction. Actually, it's a social problem as well, because if you cannot trust a public transportation system, for example, to get to a job interview, you'll not be able to get a job. Or even if you're lucky enough and you get the job, you'll not be able to trust the transportation system to commute to your new job daily. And the same is true for anything that exists in that small town, any amenities that the town suggests. So the schools, the educational system, the healthcare system, entertainment, business, sports facilities, and everything else. So as of today, those cities are very car dependent. So if you live in a small town, you have to drive the car or ask someone to give you a ride, or just stay at home. And the existing solutions could be the very well-known optimized dynamic minibuses, except that they are not financially sustainable. Again, they require a lot of subsidies. Why? It's because due to their dynamic nature, they only can function as a taxi, which means that they cannot transport more than a certain number of passengers every hour, which doesn't and cannot make them not just profitable, but even to break even. So they critically depend on subsidies. And the traditional system, which is actually quite efficient, the one with the fixed bus stops, fixed time schedules, the traditional bus is actually quite efficient, but it's efficient for big cities with a high population density and where the cities, as I have said before, can afford to run many buses, even if some of those buses are empty. So what could be the solution for the small towns? It's Tunnel. And what we do is that instead of optimizing the movement of buses and making dynamic routes, we keep the routes fixed, but we remove the timetable and we remove the fixed bus stops. And we make sure that along the fixed bus route, there are dynamic meeting points which allow passengers to board. And for the bus, it allows to pick up as many passengers at once as possible. So we could say that our focus is not making an app that allows a passenger, a person who lives in a small town, to order a bus. It's just a nice extra. The main focus of our solution is to optimize the movement of passengers in an economical way, something similar to the economical optimization of airlines. Because you see, when, for example, the Ryanair or EasyJet flight takes off, all the seats that they didn't sell are gone forever. You cannot sell them again. It's a very perishable product, so to say. And actually, the same happens to an urban bus many times a day. Every time it leaves a bus stop, all the seats that were not sold are lost revenues. So we use data and AI and geographical data to make sure that the bus is always full. And to make the use of the data to make that happen, we use a lot of pedestrian routing, which requires quite a lot of geographical data to process. So as a result, the vision is that if you live in a small town, there is at least one less reason to abandon the town and go live in Barcelona or Madrid or Paris or London. And you can stay in your small town and get a high quality public transportation through your smartphone, which can stay even when there is a pandemic, economic crisis or whatever, which can actually sustain itself as a financially sustainable organization. For this to work, we use quite a lot of data sets. So some of them come from space, some of them are from the open community, some come from different governments. We mix them, and then we use different kinds of infrastructure to actually host and process those data sets. In this case, under the experiment, we get fantastic help from 3 digital innovation hubs under the EU hubs for data. So this is one in Sweden, and actually it's dispersed all around Sweden. IDI, thank you, it's in Valencia, and Eurecat in Barcelona. So from all of them, we received a lot of support and immense support with running different kind of virtual machines where we could host and process different kinds of data. And now I'm going to explain a little bit how we actually organize the experiment. So as I have mentioned, Tunnel is not just an app. The app is actually a nice extra for the passenger. So behind this is a whole cyber physical system which uses GNSS, AI, and big data. And I'll zoom a little bit more into the actual backend part to explain about how we use them, how we benefit from processing the passenger routing data. So in this experiment, we simulated the incoming requests from different passengers. We did it in different ways. It was done through the actual mobile app. We have both the Android and iOS app. And we actually also simulated virtual passengers. So for the backend system, it actually doesn't matter if it's coming from an app or from some script. So we simulated a lot of input requesting, like people wanting to go somewhere in a given small town. And those addresses were completely random. People were trying to go from, let's say, from a hospital to some residential address, or from some residential address to the town council, to the town hall. So the system generated a lot of input. Then we used our backend system to actually process it. And to make the result, I'm going back to step number 1. We used different combinations of different map data sets to actually make this happen and to provide the actual result for the passengers, sending them the actual virtual bus that they can board, ride, and get to their destination. So in the middle of the experiment, we actually made several videos of doing that. Then later we produced quite a lot of log files for that. So yeah, maybe it doesn't look very graphical, but these are real screenshots of the system running in the infrastructure of the digital hubs. It ran for, first it ran for 1 hour, then 3, 4, 7 hours, and then we reached the final target KPI, which was 8 hours. So why actually 8 hours? Because obviously from our experience with the different researches and the experiments in small towns, this is the time which is realistic for some transportation service to be operational from the morning to the evening. Of course, it would be nice also to run for 12 hours or 16 hours, or maybe even 24/7 if it's needed. But 8 hours is something which is already very close to the market, which is something usable. And also we had 2 more KPIs. So we wanted to see that in a given small town, if there is quite a lot of demand, let's say people going to work, to school, and to some other places in the morning, and there is a peak in requests, and then there is a new passenger coming in every half a minute, we could actually accept that. And also, of course, we wanted to make sure that every order that comes in from a passenger gets the bus assigned, gets the actual passenger itinerary assigned, and the passenger can easily get to their destination within a meaningful time frame, which was 120 seconds, 2 minutes in that case. So those were our KPIs. All of them were reached thanks to a lot of input from the digital hubs, from the coaches, which we highly value during this experiment. So we can say that now it's concluded and completed successfully. And in addition to saying big thanks to EUH4D and to all the digital hubs who actually helped us to come closer with a solution which can save small towns and give them real public transportation, we also want to use this public opportunity to invite partners, municipalities, small towns. Dear small towns, if you don't have any public transportation, we are free to talk, and actually it's free for your budget. Transport operators and startups who want to collaborate on building apps, we are very interested to partner. Our URL is there on the screen. Thank you very much, EUH4D. Thank you very much for your support again. That's a success story. Thanks a lot.
Thanks a lot, Kirill. Thank you very much for your kind words. Also a very good example how the project has helped to your already existing solution to be more scalable and also closer to the market. So it's a very, very nice story, and I'm very happy to have you help on that. Thanks a lot. So now we will move to the last experiment, which is carried out by Binare.io. It's led by Andrei Kostin from Finland. So Andrei, we can see perfect your screen.
Yes, thank you, Daniel.
And we can see and hear you well. Perfect. Thanks a lot, Andrei, for being here.
Yes, thank you for inviting me and for this opportunity. Thank you, Daniel, for introduction. Welcome, everybody. My name is Andrei Kostin, and I am the CEO and co-founder of Binare.io, a cybersecurity spin-off and a startup from Central Finland, from University of Jyväskylä. We have been very happy and lucky to have had this opportunity to run the Open Call 1 EUH4D IoT CESOD project. Basically, I have some slides that have all the necessary disclaimers that gives thanks first to EUH4D and its goals. I will try to also be short to recover also some of the time. We are lagging behind, but Binare's IoT CESOD project, basically it is deciphered as IoT security software data, where we try to lay a foundation for secure and trustworthy digital Europe and EU cybersecurity. Well, this is a lot of big words, but the idea is that literally everything today is a software. One of the simplest examples, even if you buy a Tesla car, for example, most of the thing of the Tesla car is software. It's autopilot, it's automatic software updates. Everything you interact with is basically software. The hardware is important, but it's kind of the secondary to the entire thing. So everything is software these days, and the software has very unique properties that it's very flexible, but at the same time, it can be abused by attackers, cyber criminals. We have seen this coming in the last couple of years as a strong signal that we need more secure software. And in order to understand the software, especially in IoT domain, where all kinds of devices from coffee makers, blenders to satellites and cars are being connected to the internet, we really need to take a step back and understand the data behind the software, like what does the software contains, why it contains certain things, does it contain the right things, the right ingredients, doesn't contain enough or too many ingredients. So this is kind of a background information that I try to give why it's called IoT security software data. It's data about software and its security related to IoT field. So IoT CESOD aims to, aimed to run a closed loop system experiment, producing cybersecurity data sets, namely generating complete and accurate IoT firmware SBOMs, and they're always up-to-date vulnerabilities and CVE mappings. There's a lot of information packed in this sentence, and I'll try to explain. So Binary, what Binary does, it develops an automated cybersecurity platform that analyzes software and firmware, general software and general firmware, but with particular focus on IoT and industrial IoT firmware, where we take those firmwares and we automatically analyze and try to find vulnerabilities with the goal of notifying the users or the vendors of those software and firmwares that, hey, there's a vulnerability in this package. Maybe you want to take some action to remediate this vulnerability so that the system and the device is secure in the next iteration. Now, the idea is that we put this goal as collecting a large number of firmwares. I'll get to the data set a little bit down the line. And using our platform to improve the platform, first of all, and also to generate all the data using our platform. In the end, we obtain what is called SBOMs, which is a hot topic these days. SBOM is a software bill of material, and you can think of SBOM related to software, similar as you see the ingredients lists and nutritional facts of a product when you buy from the supermarket. For example, when you buy a bread, it contains the exact nutritional facts, how many fat, how many sugar, and so on it contains, and what are the ingredients, the exact type of components, egg and salt and whatever, and how much of it. So SBOM is similar for software in this way, but it contains information about what libraries, what software, what different software components, what configuration is contained within a whole software package or firmware package when you put it on a, let's say, router, printer, VoIP phone, or even a satellite. So the idea is that once we have that information, it is very important information because we already can map that information to what is called vulnerabilities or CVEs. In a way, it is very similar again to the products where if you have certain colorants or taste sweeteners which have these E codes, E123, E621, and some of them, these are the codes for very complex chemical compounds. And in many ways, certain of these codes are known to be linked to, let's say, medical problems. So in the similar way, the SBOM components, they are known to be linked to certain vulnerabilities or security problems. And this is kind of one very important step that we did in this CESOD project. Some notices before I go into detailing a little bit the data set, but thanks to European Union and to EU Hub consortium and project for funding. And also this is a standard disclaimer that we want to use as suggested by the EU allocation of funds. And the views of this project is basically the views of Binary and doesn't necessarily represent all the views of European Union or EU Hub project. So without going into the details of the experiment, which I can explain for anyone who is interested in just reaching out to me or reaching out to Binary, and we can explain in more detail and make a demo. But the core of the EUH4D are the data sets. So this is what I try to focus on today's couple of slides. So we've carefully selected 215 vendors to try to represent the most significant vendors in the IoT firmware space, and also that provide devices for a variety type of ecosystem, not just routers or IP cameras, but also electric chargers or things related to industrial settings and so on. So we had about 178 device types, and these device types means, for example, as I mentioned, a VoIP phone category or a router category or a satellite category or some avionics system category. So in total, we had 178, which is quite big. And of course, it can be very fragmented and very unbalanced because, for example, for satellite, we get one firmware, and for routers, we get hundreds of firmwares. So the data set is a little bit unbalanced, but we at least get the taste of the entire spectrum. And we've collected about 14,000 firmware files, which is quite beyond one of the KPIs that we have set in our project. So once we've collected these 14,000 firmware files, our automated processing platform, as I mentioned, which we could also scale thanks to the hardware and cloud infrastructure or platform as a service infrastructure provided by EGI, we could scale it quite well so that it can process all that files that resulted in for almost 13 million processed files. And the total storage and all the data processed back and forth and all the analysis performed resulting in about 1.5 terabyte of data being collected, stored, analyzed one way or another, which is quite a big number, I would say. So once we have completed the analysis of these, so you can imagine we started just from a very small number of 14,000 firmwares, which is not quite big, so to speak, but the number of files that resulted from analyzing those firmwares is 13 million. And then this is where the big data or the huge data analysis comes into action. But we've been able to map more than 300,000 software components, meaning all kinds of libraries and, for example, OpenSSL. This is one of the most common libraries used across the software because of its security, HTTPS, encryption, decryption functions that it offers to the developers easily. So we've discovered in total more than 300,000 components across the entire firmware spectrum. And generally, there were about 30 software components, like third-party supply chain components in each of the firmware, with some firmware containing up to 100, 120 components, which is a huge number if you think that you are trying to say a firmware with just, I don't know, just turns on and off your screen and it contains 120 other software components. It's a huge number, and the security and the attack surface is really big if you think this way. Then we have analyzed all the components. Here's a short list of 10 most common components that we have seen. And you can see some of them are related to libcrypt, encryption, decryption. Some are libgcc, which are related to GNU C compiler. So many of them are compiled with GCC suite. Also NTP client, a lot of them are querying the NTP or time protocol from the internet. So it's pretty common. IP tables and PPTP are used in networking. So all of these are network or communication related devices that are connected to the internet or some network one way or another. The idea is that in total, there were about 3,000 distinct components that we could track and monitor. So we already have a list that these components might bring certain vulnerabilities into the game. More importantly, we have also analyzed all the data, and from all these 12 million files, or resulting from the 14,000 firmwares, all these files, basically, we've been able to map them to at least 7.9 million vulnerabilities. These are not different vulnerabilities. They, some of these vulnerabilities, they are occurring in more than, like, the same vulnerability might occur in more than one firmware. But the total cumulative number of vulnerabilities is 7.9 million, which is a huge number. If you imagine that for a human analyst to process these 7.9 vulnerabilities by hand to confirm them that this vulnerability is applicable or is exploitable or is dangerous or is not dangerous. It's a huge number of data to process. So of course, human analysts cannot handle this, and this is one of the first steps to have this data in order to build machine learning paradigms on top of that. Again, we also make some statistics with the top 10 vulnerabilities. Many of these shortlist top 10 vulnerabilities are related to Linux kernel, which is more or less expected because many of these devices or IoT devices are based around or developed from the Linux kernel or around Linux kernel. We also have found 0 days, but we have responsibly disclosed to the vendor. The vendor is a huge one, Gigaset from Europe, but develops enterprise VoIP communication and also smart home solutions. We have responsibly disclosed that, and we had very good interaction and supplying all the information. So this report is now public, and the problems should be fixed in the next firmware versions of that vendor. Overall, the data set and the data experiment was a huge success from our opinion because it enabled us to create the data set. And with that data set, we've been able to also explore other opportunities, other European projects or other collaboration opportunities where the data set can be used for AI machine learning or to be used in more specialized high performance computing environments, for example, but we've been talking with EGI. But we would like also to thank our three mentors and partners or DIH partners that supported us. The Know Center, Barbara and Angelica and Christoph, they supported us very well from the business side, mapping our business strategy, how we could use the data and how we could use the platform in combination with the data and what could be the next steps. So we appreciate that so much. Very importantly, we appreciate the EGI, and thanks to Elisa, Andrea, and Levente. I think this EGI support was the infrastructure and the human communication for setting up the infrastructure was crucial so that our platform could run smooth and we could scale it quite easily to handle such a big number of vulnerabilities and files and so on. And the storage and everything was fine. And I think without that support of HPC, maybe it was not so great success, so to speak. And also we would like to thank Siadar, Ricardo and Andres and Aditya and Vivek for their good insights of how we could apply machine learning and artificial intelligence after the project is completed, which we actually are going in the next step. So I think next couple of weeks, I would say we should have some more visibility into a continuation of building some machine learning and AI model on top of this data set that we generate as part of another project. Once the details are finalized, we will make them public on our pages and everything looks positive. So I think it's a great success because again, besides the results that we've achieved and all the KPIs being achieved beyond the initial targets, it also enabled us to diversify and see the continuation of this data set. So the data set is being carried forward in another projects of collaborations. Last but not least, the ETI, thanks Daniel and Guillermo and Vanessa and Sandra for providing all the logistic support for running smoothly the project as part of EU Hub for Data in general. So again, thanks everyone. You can always contact us through our pages or through the emails or just approach me directly online or physically. And thanks again for the opportunity to present today and for the opportunity to run the IoT CESO project in the open call #1 of EU Hub for Data. Thank you so much.
No, thanks to you, Andrea, and also very kind, not only to mention the partners, but the people involved. So very kind. I hope they are all of them are following the webinar, so they will feel quite comforted by seeing their name here. Thanks a lot. Okay, so as you have seen, a whole portfolio of experiments, quite varied and quite for us really impressive. We are really proud and really happy to have hosted those experiments. Thanks to all the presenters for being here, for your work and your presentations. It is really very much appreciated. And now we will move to the view for my colleagues in the project, from the partners, from different perspectives. And the first one will be Till from the Karlsruhe Technical Institute, providing our findings and views from the ethical perspective. So Till, I can see you are ready, so the floor is yours. Thanks a lot. We can see your screen perfect.
Thank you. Hopefully you can also hear me. I'm just, yeah, there's the bar actually hindering that, but yeah. So I will be very quick, and I think if there's upfront, if there's any questions or ideas or input on this talk, I'm really happy to follow up on this. It's a really interesting journey, this project, and what's actually behind ethics, there are a lot of things hidden, but we want to really say what we want to establish when we're doing all this is we want to see ethics also as an innovation opportunity. The challenge, though, anybody who's dealt with ethics in the Horizon 2020 project or kind of understands also the implication of what's actually meant by ethics often can see that it's rather around risks and handling risks rather than opportunities. And what we are trying to raise in this project along the experiments, which are really great to see actually all the ethical challenges, is continuous awareness and want to improve, because it's all about, I think, data economy, what we are talking about, how will the future data spaces look like, and what kind of a data space in a project looks like, kind of simply contractually, and there's tons of laws and regulations around it. I don't want to go into that, but it's complicated. And in the center, there are the SMEs. The SMEs are the responsible parties for enforcing ethics actually anywhere, because they're doing the experiments. So you would expect them to be in this real center of everything. But how can we help them? Daniel said, well, we are providing catalogs with data. We're helping them to look at, to basically find interesting data sets. And you've seen a lot of interesting data sets actually presented. And there is one example, for example, from an experiment. So we are providing services and also data sets. And in these data sets, certainly things can pop up, like there's personal data in that. And that's actually a huge deal when we talk about ethics, actually practically. It's how to do, what to do with personal data. And this data is public. Actually, this data is published on Zenodo, and everybody would assume, oh, well, this is kind of Creative Commons data and so on. But the question then arises, if you're using this data, what was actually the legal basis for consent of processing, because it's still private, so it's still personal data in this sense. I'm also, actually, this is like around wording, there's this biggest confusions. There is privacy, but it's personal data means that the data is actually related to persons. And the question here is, yeah, can I really use this data? Was the consent given for the use, for this innovation use? And this is huge challenges. So actually, delivering catalogs on this side is important for the projects. And these catalogs need to improve. Actually, the classification changed. It says this particular data set, for example, it says, okay, it's no personal data, but it contains pseudonymous user IDs. And for them to be really anonymous, we have to prove the effectiveness of anonymization. And it's really challenging for an SME actually to do this. And I think as a general thing, we need to improve really as a data spaces and so on in supporting the SMEs. So what we're doing is reporting this, and there will be a public report published soon. We are just awaiting the final comments from the reviewers and the clearance from the commission. And what the project is really also about is reporting to others who want to do these experiments, the next rounds, to what to do. And the biggest challenge is really being fast, innovative versus compliance. And we need to deal with these conflicts that are just around in these projects. And like I said, it's just with wording. You heard Gaia X, and if there's the International Data Space Ban, and it talks a lot about data owners. I don't like the word data owner, because if you come to personal data, well, who's the owner? The person, actually. And then we're basically having tons of terms and complications, and it's really difficult to understand this. And the second thing is kind of the challenges that we are facing here. And we didn't expect to find so many things when we started, but it's natural because ethics conflicts are inherent in data-driven innovation. And what we need is processes, awareness, and things around this. And we heard about the SS Sleep, how difficult it was to actually get kind of approval, because you're in the health domain, you need ethics approval, you need medical device approval in the end, if you want to bring something to a market. And there's tons of regulations to be compliant. But there's even a bigger kind of dimension to it. So if you really want to think of ethics, you also want to think about trustworthy AI, what you do with the data, and there will be upcoming regulations. And they are also a risk at the moment, kind of to SMEs who want to bring this stuff to market, because they might be regulated. And I think, like, at current state of discussion, 4 out of 10 experiments might be regulated in the future by the IAC as high risk areas. And what is this high risk? I mean, we have a project that is around financial credit worthiness scoring, so access to credit. But as it kind of, you understand how valuable this is on the European dimension, but as kind of as an individual, you want to make sure that the stuff is trained fair and so on. Other things are like, it's a drone monitoring product, but it's around digitalization of power lines. So it's our infrastructure in Europe, and everybody who has followed the discussion around Ukraine war and all these things is how we see how important, especially energy, can be. And we are trusting now data, and we're trusting systems built on data to maintain those systems. So we need to think about it simply. We heard before the IoT project, and kind of they nicely discussed how important is like responsible disclosure. And same thing, now we suddenly are in the middle of a war, also cyber wars, and it's becoming important that we're handling this information responsibly. Yeah, and there, for example, also the tunnel project. I mean, we're saying, okay, we are economically optimizing and so on, but we should think about also what impact also bad OpenStreetMaps data, where people don't have the economic wealth maybe to improve data, could have impact on such things. So this is an ethical dimension every SME kind of basically should think about when doing this. And it's difficult because like you want to bring the business forward and you don't want to always care about ethics. So the idea is actually provide more service to that. So, and really start also in the project to establish practices like AI assessment, trustworthy AI assessment, but also bring more training, more service around this. And we are still can improve that. And we're having the first service really on ethics on that, but really also as a project, we understood kind of from the experiments that we need to improve on that. And it is really important to have especially local and domain specific support on this. And this is how important also this federation we're building is for this domain of ethics of this project. And in the project, we have a lot of people that I'm also kind of representing here, just in a sense, because they look at this ethics. We have the ethics monitoring group. We have a really good ethical advisor in the project, and we really want to improve really the project as we're going. And as was said before, this is really about experimentation and learning. And I want to point out after this session, there is also a session on algorithmic bias in AI. So from Francesco, who is really also in the ethics group. So this has many domains from simple compliance to basically advanced topics like fairness in algorithmic fairness in AI. And that I want to conclude and want to show you how complicated this is, but also how exciting actually the space is, and how we can basically all together in those kind of experiments improve on those aspects and really build something that can be sustained around Europe. Thanks.
Thank you, Dil. Well, you're completely right. We never thought at the beginning how much importance ethics were going to become in our project. And also we are learning on the fly. So thanks also to the experiments, because we are also learning from them and they are also learning from us. So it's a cooperative process for all of us. So now I will give the floor to Adriana, who is the exploitation manager, innovation manager of the project, and she will talk a little bit more about, okay, the exploitation plans that we are studying, we are following with the experiment. So Adriana, we can see you perfect and your screen.
Hello,
Thanks,
Daniel, and hello everyone who is attending the workshop. I'm Adriana Botnari from Karsta, and as Daniel mentioned, Karsta is leading the tasks in the EUH4D project related to the exploitation. And here I will briefly present you what we have done in terms of exploitation plans for the participants in the experiment for the first open call. I don't know why I cannot, okay. So I will give you an overview. We have a specific task for that. It is called Exploitation of Results. And within this task, we aim to offer support to the participating companies in the experiments in terms of exploitation of their results coming from the experiments they are carrying out. And we aim that at the end of their experiments, they will have a successful exploitation plan, and they will be able to exploit their innovative ideas and to reach the market. So why exploitation of results? Because we consider that there is no result, no innovative result if you don't exploit properly. So for this reason, we are collaborating with the SMEs participating in the experiments to help them to exploit the results and also to reach the market, and why not to increase sales. Here you have the work plan for the exploitation of the results, and we have already completed the first plan for exploitation of results for the first open call, and 2 more plans to come in the following months. But for this, we will be working with the next experiments. So why we were focused on individual exploitation plans? This is because each of the experiment is different, is particular. For this reason, we didn't work on a common strategy, exploitation strategy that they could use, but we focused on helping them to develop individual exploitation plans for each of the experiments. And for this, we help them to collect and describe their exploitable assets that are coming from the experiment. We help them to understand what are the main assets they can exploit, and which ones can bring an added value to them and to the market. So for the first round of experiments, we helped the experiments. From 10 of them, we were able to develop only for 8 experiments. One of them did not achieve the expected results on time, and we will be helping them for the next round. And another one didn't achieve any exploitable assets. For this reason, we were not able to help them in developing an individual exploitation plans. But as exploitation activities, we did that together with the experiments, the identification of key exploitable results, and also we supported them in developing their exploitation plans. Here I will present you briefly the methodology we have used. We split it into 2 phases. In the first phase, we identified the area of interest. Then we drafted the individual exploitation plans. And in the second phase, we revised the individual exploitation plans, and we have performed a diagnostic check. And based on the diagnostic check, we have decided on what sections needs to be improved, and we have formulated specific action points for each of the experiments. An important instrument that we have used in implementing our methodology was the data exploitation tool. We have developed two versions, one dedicated for the SMEs participating in the experiments, and another one was dedicated for the DIHs. And based on the information we have collected within the version dedicated for the SMEs, we have basically drafted the individual exploitation plans of each of the experiments. So as you can see in the first version for the SMEs, we have two different chapters. In the first chapter, we have collected information, general information on the experiment as objectives, motivation, and opportunities. And then in the second chapter, we mainly focused on the exploitation plan. Here we have collected information on the exploitable results, on the business potential, on the revenue potential, and also we encouraged the SMEs to think and reflect on what is the competitive environment. So based on this information, we were able, in fact, to develop their individual exploitation plans. So here you have the 6 steps we followed together in parallel with the data exploitation tool. So here you have also some specific section that we have included in the data exploitation tool. And then I will give you an example on how we perform the diagnostic check. So we had specific quantitative and qualitative evaluation criteria that we have used in order to decide on which sections were well developed and which sections needs to be improved. And based on the results, we have classified specific section in a different scale as low, medium, and high. And those sections that were evaluated as low or medium, we have formulated for them specific action points. Here you have some examples of action points that we encouraged the experiments to follow in order to improve their exploitation plans. And also in order to improve our methodology for the second call, we provided the participant in the experiment with a satisfaction survey, and based on their answers, we are going to adjust and improve our methodology in order to have better results for the next steps. Thank you very much.
Thanks a lot, Adriana, for explaining the exploitation strategy that we are following with the experiments. So we are running out of time, so we will move quickly to the next speaker, who is Nuria Dalama from IDC. They are our impact experts, so she will explain a bit more details the impact that we are gaining with the experiment. So Nuria, thanks for being so quickly, and the floor is yours.
I didn't start yet. Thank you very much, Danny. Can you see my slides?
Yeah, perfectly.
I know we are doing very bad with the time, so I will try.
No, it's okay. It's okay. Take your time, and well, we are okay. We can manage. Don't worry.
Okay, in any case, I will not go into the details. My name is Nuria Dalama, I'm Consulting Director at IDC, and as Danny has mentioned, we are involved in the EUH4D project, taking care of the impact assessment. And I like this presentation because somehow it builds upon the results that all my previous colleagues have already presented, and also it takes into consideration many of the experiments that have been presented today and the ones that are not here. So the first thing to say is that it's very important to measure things, because normally we have the impression that we are doing quite a lot of things, but then we always need to relate the amount of money we are investing with the results we are getting. So I think that having quantitative indicators is always a way to measure, first of all, the progress with respect to the objectives we set in the beginning of the project, and second is a way of comparing if what we are doing is really worthwhile and which instruments are having better performance than some others. So the first thing is that looking at the objectives of the project, we define a set of areas where we have identified a number of key performance indicators. In the project, for those that are not involved in this one and maybe our external audience, just to tell you that we have like hundreds and hundreds of particular key performance indicators, but as mentioned, all of them fall under the categories of, first of all, access to data and data sharing, since this is one of the objectives of the project, enlarging the federation, since one of the ideas is, of course, make the offering very strong strong and ensure that that is sustained over the time. Then engaging SMEs, of course, it doesn't make at all sense that we have a strong offering if we don't have a demand for that. Quality and satisfaction, since of course, besides putting the things on the table, it's important that the quality of the assets that we are offering and the satisfaction of the users of the infrastructures is high. Improve data skills, because we understand that SMEs and startups do not only need access to infrastructures and technologies or also data, but also improving the skills is quite important to ensure that the data economy flourishes. And then of course we have a number of KPIs around communication, and I will not talk at all about those ones today. Just to give you some important figures of the project, I think this could be important for the people that are not involved in the project to understand what is the scale of what EUH4D is doing. I think that the first thing to say is that, as mentioned, one of our objectives is creating a critical amount of data sets, and this is something that we have already achieved. For all the KPIs, basically we take into consideration the baseline, then we measure how these numbers should evolve along the project, and we tend to measure all the KPIs normally in the periods associated to the reporting period for the European Commission. So we define, for example, targets for month 18, and what I am providing here is basically the numbers that have been measured in month 18, but of course now they have evolved because we are a bit later in the project. So in terms of data sets, we have already achieved 160 open data sources, 60 repositories and 100 individual public data sets, and 14 new private data sets coming from the experiments that have been presented today. I think this is important because one of the things that I'm trying to do with this is offering numbers also to give publicity to the resources that we are offering to people from outside the project. I think that the main thing today is that you see how successful these SMEs have been in running their experiments and how useful these infrastructures and technologies can be for further experimenters that come to the third open call that Danny mentioned in the beginning of the presentation, or for people that want to work with us, even though it is not through the open calls, which is also possible. So please get in touch with us if that is your interest. Then besides increasing the catalog and the number of data sets there, we are considering the volume, and we are also considering the number of new data sets that result out of the cross-border experiments. And for this, as mentioned before, 14 newly public data sets have been shared, and there are also 14 more that are private, somehow involving the internal experiments, but are not offered to third parties. We have a number of KPIs that have an intimate relationship with the topic of today's workshop, basically with the SME experiments and the performance. Unfortunately, even though the KPIs are defined, the problem is that you've seen that experiments have finished quite recently, so there was not enough time that is realistic in order to measure some of these KPIs that have to do with the success of the SMEs, even though you can already extract some lessons and some impressions about how good they are. And one of these KPIs, but you will see that in the next period of the project, has to do with the higher performance of the participating SMEs compared to industry benchmarks. The previous speaker from CARSA already told you about the exploitation plans, and as part of all these exercises we are doing, basically all these SMEs will be measured against these industry benchmarks, showing and proving in a realistic way that they are doing better than before they entered the project and they were able to use all the infrastructures. For all the KPIs that have to do with these SMEs, basically I have tried to highlight them with these orange boxes so that you get a better view on which ones are relevant for today's discussion. Then something that is quite important is the federation and how we have enlarged that. It doesn't have to do very much with the topic of today, but just for the people from outside the project, basically we have 30 digital innovation hubs in the federation covering 30 regions and 20 member states. So I think that from the point of view of the supply side, the offering of the federation is really strong in terms of coverage. Coming back again to the SMEs, I think it's important to mention some of these KPIs. One of them is revenues. Again, as mentioned before, we didn't have enough time to check how impactful the experiments have been in the revenues obtained by the SMEs, but this is something that you will get soon. Probably this will be confidential, but in any case, if one of the external people is interested in understanding a bit better the experiments and the figures behind the SMEs, get in touch with us and we will check what can be done. I think that what it is also interesting is the amount of SMEs that have been attracted, but this is more operational related to our open calls. Quality and satisfaction, however, is quite interesting here, and we have achieved a high quality, high satisfaction from the different users of the infrastructure. That is important. And then Also the fitness to market, which is a KPI that has to do with the previous category that I mentioned before, and that for sure has not been measured yet, but will be done in the future. However, what it has been measured is the number of innovations that we have already achieved in the project at this stage. 20 were expected by the end of the project, and now that we are still only in month 18, basically 13 innovative solutions have already been documented. They will be published in one of our deliverables, and as mentioned by Till before, the deliverables have not been published yet on the website because we just recently have the review and we need formal approval for that, but they will be soon available through the website. And then in any case, what it is important, and I encourage you to do, is visiting our website, because many of the characteristics and many of the data that have been presented today around the experiments is exposed already in our website of the EUH4D project. So 10 experiments are featured there. You can find pictures, you can find descriptions, you can find quite a lot of information, and quite interestingly, you can also find concrete KPIs related to each of the experiments and not just the global impacting figures that I'm presenting today about the EUH4D project. Then skills is also something important, but I think that today we don't have time to go through this in detail. However, you will have the slides and you can check our figures and also access all the resources we have created that can be used not only by the people participating in the project or the SMEs applying to the open call, but also by any external person that is interested in that. So something that is important is to highlight basically which are the KPIs related to the experiments where they are contributing. First of all, the usage of datasets, the generation of new datasets, the creation of data-driven solutions, either product, services, or both, and then also the creation of new jobs and the potentiality to hire new people, which is what we really want them to do. I think that today I will not go in detail through this because the experiments were already explained, but basically I extracted data related to two of them for a tunnel. They were explained before, as I mentioned, and for each of the experiments, what we are doing from the point of view of assessing the impact is understanding also the way they are getting better in terms of technical performance. I think that it is not just that EUH4D is enabling them to do things that they were not able to do before, but also that we want companies to do things better. So they need to be better in comparison to the benchmarks, as I mentioned before. And for this, we have selected a number of technical KPIs that change quite a lot depending on the experiment, as you can imagine. And we are measuring them, what was the baseline before the experiment and basically what they are able to achieve and what is the difference in comparison to other solutions that are in the market. I think that will be quite important input also for the people who want to use our services. And let me finalize my presentation. I'm sorry that I'm going so quickly because I know that we are not doing very well with the time. I think it's important maybe to highlight some conclusions. And I always like calling them opportunities even more than challenges because I think that in general they are quite positive. So I think that first of all, looking at the role of EUH4D in developing the data economy, I think that a project like this one is very important and is key in order to generate new data sets. A lot of companies are claiming that they don't have access to enough data sets to develop their business. So we are somehow contributing to different objectives. On the one hand, using existing data sources. And I think that today you had the opportunity to look at the way some of the experiments are using publicly available data sources like geospatial data that is already available, but not enough used. And then thanks to the experiments, we are able not only to use the data sets that already exist, but also generate new ones and foster data sharing. So the three things are important and we have shown that we are really progressing towards the three of them. Another aspect that is quite important is that we are not just providing access to technology or to infrastructures. Digital innovation hubs were doing that before EUH4D came into place. I think that the important issue here is the federated pan-European approach. And why is this needed? I see basically two justifications for this, which are quite important, by the way. First of all, is because in this kind of global environment, I think that every time we will see more cross-border services. So just working with infrastructures that are providing support at regional level can be important, but I think that at some point in time for the provision of cross-border services, you really need different kind of services, and for sure the ability to deploy your application in different countries, get support based on the different, for example, legislations at national level, and all this is possible thanks to projects like EUH4D. And then if we think about an application that may be executed just locally using data sets that are available locally, maybe in the context of a city, big or small, or in a context of a region, then still I think it is very important the role that EUH4D play in federating the infrastructures, because they will allow basically for SMEs to scale. And I already heard one of our experimenters talking about scaling their business. So I think this is very important because we don't aim just at creating an application that works locally, but also at the ability for the SMEs to replicate the applications in other regions, in other countries. And for this, again, you need this kind of support EUH4D is providing. Then to mention all these ethical implications, I would like to add here also the word legal. And this is quite important because thanks to these experiments, we have learned quite a lot about how to apply these technologies in concrete settings and in concrete vertical industries. And in fact, we had a review quite recently, as I mentioned before, and the European Commission encouraged us to create an asset, something that can be exploitable out of all these learnings from the ethical point of view. And I think this is a kind of, I call it actionable consulting for SMEs that EUH4D is ready to provide or will be ready to provide in the short term. So if you are an SME, you are experiencing all these challenges, I assume that you don't have maybe the money to pay just one person to take care of these kind of things, as maybe big companies may do. And I think that here EUH4D can also be quite key and instrumental for your experiments to go ahead. Finally, something that has to do with basically the work IDC is doing in the project, measuring indicators is key, because normally we tend to talk based on impressions, but impressions are not always true. So since we are really developing business based on data, I think it's also that we take decisions based on data. And for these, having not only the qualitative indicators, but also quantitative indicators that measure in reality what the impact is based on the investment is really important in order to convince other sources to invest in what we are doing in EUH4D. So far, we are doing quite well, but again, we are really proving that with figures. And finally, I would like to highlight the message that Anna and Danny provided in the very beginning of the workshop related to sustainability. I think we are doing a lot. Still, there is a long path ahead of us, but of course, supporting this with more DIHs that join the Federation, with more SMEs that really want to use all the offering, it's very important, because I think that this is something that requires a long-term perspective and therefore long-term effort that should be sustained along the next years. And with this, I conclude my presentation, and I hope that this offers also a quite general, more data-related view of what we are achieving in EUH4D, and I'm ready for your questions if that is the case. Thank you.
Thanks a lot, Nuria. I couldn't agree more with your last slide and the messages about the importance of measure with the real quantity the impact, and also about the future, where to emphasize and where to put our effort for the future. So thanks a lot for your presentation. And now we will move to the last one, which is from our colleagues from Digital SME Alliance. So we are very lucky to have the Digital SME Alliance as partner in the project, because they provide this. I think Justina is in the call, right?
Justina is here. You cannot see her because indeed I noticed there is something wrong with my camera. So you can imagine ghost Justina in there.
Okay, perfect, Justina. So great that it's a bit weird, but it's okay. So no, I just was saying that we are very lucky to have you on board of our project, because you provide this view from the SME's perspective, but at the European level, at the European limit dimension. So we are really happy to have you here and look forward to what you are going to tell us. So the floor is yours.
So thank you very much for presentation, Daniel. I will try to be very, very short, so that I know that we are a bit out of time. And I will try not to get a lot into details with all the background of the EU legislation and the given situation and the status quo, because I think we are more or less aware of that. But briefly, Commission has very ambitious targets. So 75% of EU companies should be using big data, AI, cloud infrastructure, so basically all types of data services by 2030. And more than 90% of SMEs should reach at least basic level of digital intensity, meaning again, making use of data, if not as their main business model, then at least to support whatever services or products they are selling. Meanwhile, the status quo is not so encouraging at the moment. we have much more large enterprises than SMEs that are reaching a higher level of digitalization, and also there is a real and uneven level of digitalization spread across Europe and between different regions in Europe, and also the spending on ICT-enabled digitalization is much higher in some parts of Europe compared to the other ones. And here Commission already a long time ago has proposed digital innovation hubs, and the concept of hubs as one of the solutions for that. And we are here in this discussion are well aware of how hubs work and how we help SMEs. Here in our membership in the last years, we were working on also advising Commission of how to develop the European hub network and so on. So we were very active in trying to understand what is it that SMEs need from hubs the way we are now, and what are the needs and how we could be further improved through the European federated network of hubs. So here I have a brief list of main needs of SMEs with digital innovation hubs in general. So of course we need offer of services to be demand driven to answer their specific needs, and we don't want any duplication of services that are already in the market, since those we can also buy from fellow SMEs, from their peers, or already get from any other companies that are in the market. So what hubs are doing should be a little bit of on the top from what we can easily access. We of course need access to financial support, so be it in general to further development of their services or products, but also to fund the digitalization projects that we are overtaking in the companies. Of course, we need knowledge and guidance for starting digital projects, since many of them do not have staff or have very limited members and staff to run these projects. So they don't even know what to do and where to start if they want to go further in their maturity level and they want to further proceed with digitalization of what we are doing or use of data. So we really need some kind of help in managing the knowledge of how to step from step one, the data we have now, to something that would create a bigger value in the future. Of course, we need support and compliance with the EU legislation, for example, new AI Act, but also other older legislations that are out there. And we need support to access different markets and internationalize, since we are quite good locally or in the region, but we learn that many of these, especially micro-size SMEs, have difficulties going into wider markets outside of their country. So it has something to do with legislation as well, since not everything is legislated on the EU level, and sometimes there are country-specific requirements, but it also has a lot to do about reaching clients and markets in general. Finally, there is a problem of language sometimes, so there are still issues in accessing some services, or especially finding their services and getting trainings that are in languages other than the ones that are in the SMEs country. So how does the EU Hubs for Data and generally Federation of Digital Innovation Hubs can help and answer these needs? And we think that this is really one of the solutions, to have this European federated network, which could help to answer these needs of SMEs and could provide much bigger and much better value to these SMEs compared to just one local hub. And we already see that from all the excellent examples that we had today from our SME experiments. But perhaps to have a bit of general and big picture here, I made the slide to summarize a little bit how we answer this need of SME. So first of all, of course, we have a wider catalog of all types of services provided by digital innovation hubs. So SMEs can access, instead of a few services offered by the local hub, the ones of a big variety. And currently in EU Hubs for Data, I think we have more than 170. So we are reaching 200 of different services that SMEs could access. And for this, we do not need to speak any other language. We can just come to their own local hub, and it will help them to liaise, to find a solution and to access further services or different data sets that we need. So indeed, this is a big support already. Then, of course, digital innovation hubs provide information on access to funding, but here EU Hubs for Data plays a very, very important role. So we saw these great experiments today, and they are funded by EU Hubs for Data to carry out these experiments. experiments. So for any SME that would like to start experimenting with data we have, or to proceed with data services, to adopt something new and experiment, to start that and to find the solid ground to keep off the digital project we have. Our project is offering some funding, and of course we will have a third open call running from September. So any companies that look for advice on access to finances, of course, can get it from digital innovation hubs. But to kickstart what we want to do, we can definitely come to EU hubs for data. Then, of course, various services and legal advice to support the compliance is provided by different digital innovation hubs. And if there are questions from SMEs about compliance in specific markets, of course, through the Federated community of hubs, we could get information about specific requirements in the country that we want to start their business or expand their business, even if certain requirements there could be different than in the country of their origin. So in this case, also the Federation is very helpful, because in this way hubs can easily get information about the requirements elsewhere. And finally, we have more than 15 different countries that our federated hubs are located in at the moment. And of course, Federation always has a prospect of growing even further inside of EU, but also outside the EU, since there are major plans of the European Commission to expand the concept not only in Europe, wider Europe, outside the EU, but also in the partnership countries. So we know there are many activities going on in Africa, also in Eastern Partnership countries. So what is now a federation that we have within EU hubs for data, it can in the future grow even further by new data-driven hubs joining in. And that definitely, again, helps SMEs a lot to access the new markets also outside of the EU area, and get services to know better how to grow out there. So all of this, I think, is exactly what SMEs are looking for. And the only thing and the main step that we need to do now, after we have solid grounds for experimentation for SMEs, but also for the Federation, is to raise SME awareness about what is going on and what they can receive from digital innovation hubs. And but actually everything what we need is already more or less out there, and we just need to find us and start basically working with us. And for that we have our SME roadshow. So here is a link where you can find more information, and we will have more local and European level events coming up where SMEs can get a lot of useful information. So any of you who are following the panel today, feel free to share it with SMEs in your network, with your colleagues, your peers, since they might be interested to get all the information from a bit of basics, because we know that many SMEs are still not aware. And that will be possible, again, through our roadshow. So that's it. Thank you very much.
Thanks a lot, Justina, for your presentation. It was very quick, but very also valuable. Also, I encourage all the people to check the roadshow that we are in our webpage. Quite interesting. Also, if you are interested, feel free to contact Justina or any of us. Okay, so I will just let me share my screen again, because this is just I wanted just to share with you my last remarks. First of all, okay, to let you know that the discussion will continue in Naples on the 18th and 9th of June, where we are celebrating the physical event that will culminate these 2 weeks of discussion, workshops, and a regional session, and so on. So we encourage all of you to join us in Naples. It will be a great opportunity for all of us to finally meet together after those 2 years of virtual meetings and so on. And for us, for EUH4D, it's also BDBA. Again, it's a nice opportunity to meet physically with the whole community. We are organizing a dedicated session to SMEs again in the morning of the 8th of June, devoted to challenges and value to SMEs from this data-driven ecosystem. And we are also organizing a session devoted to hubs and how the hubs could help all the actors in this ecosystem to bring closer to the challenges and success. So again, join us in Naples on the 8th and 9th of June, and you can register in the webpage of the event. And again, we look forward to meeting you all in physically there. Okay. My last comment, just a reminder of our open call. Okay, we are launching our third and last open call for experiments after summer in September. So you already heard from the SMEs involved in the first round what we are doing, the different support that you can receive from us. So please stay tuned, and if you have any question, you can already contact us. Okay. So this is all from my side. I want just to thank again first the innovators that were here with us today. Really happy and really glad to have heard from your first-hand experience, what you have done with us, and also thanks to my colleagues from EUH4D, usual very nice work co-organizing this session with me, and I wanted to thank you all. Okay, that's all from my side. I hope it was interesting for all of you, and with that we will close the session. Thanks again. Bye bye.